Manapouri Underground Power Station. Because we've got such a nice little tidy group today, I can show you a few other things. And on the walkway down here, we've got a few little objects that are sticking out from the wall. There's a story with each one of them, and we've got some stalactites growing out of the ceiling further down this attic. So we'll stop and let you have a photo up there as well. On the walls here, though, we have a memorial board, which is paying tribute to the 16 men that gave their lives for this power station to be built. Back in those days, in the 1960s, health and safety was not job number one, I can tell you that. So, well, certainly we will talk about that. But have a look at this surface of the rock here. This is kind of shotcrete, and it's part of the stress relief of the new surface of the tunnel soon after blasting. We have rock bolts and hundreds of rock bolts in the ceilings through here. Their job is to squeeze the surface of the rock back up into place after blasting. Especially around this area here, the rock relaxed as much as 15 millimetres, which is quite a considerable amount of relaxation in rock as hard as this. So this shotcrete here, that's its primary job, is to support those ceilings. Over the years, little cracks in the mountain have appeared, a little bit of water coming through, and that water's leached a little bit of the lime from that shotcrete and created these little stalactites here. Now these are just little fellows here. We call them lime straws here. So, but further down we'll stop and let you have a look at the big ones. Okay, this area here, when they blasted through here, they ruptured a little, what would you call it? You'd call it a reservoir, a water reservoir under severe pressure in the rock. Probably water that's millions of years old, and this water was just rushing out at the guys working here. So their simple way of fixing it was to drill straight into that crack in the rock, or the hole that they'd made, and ram a big tube in there and fill it full of high pressure cement. Now they didn't expect to have tourism through here, so as you can see the end of it is pretty rough, and they just hacked it off with a gas torch. And you know, a little bits of water seeping through still after all these years. Anybody going to taste it? It's perfectly clean, perfectly tasty, won't do you any harm. So there's a few of these coming down as we come down the walkway. This rock bolt here consists of a flat plate, a knuckle, a nut, and a shaft that could be anywhere up to 3 metres long with an expanding head on it. Some of them are locked in dry, and some of them are cemented or glued into place. And of course this is what helps to squeeze the rock face back together again. So as I say, there are hundreds and hundreds of these through the station. It's normal practice to fit them. They still look exactly like that, albeit new, today when they put them in. So that one's been in almost 50 years. Way back in the late 1950s, when a company was formed in Australia known as Comalco, and Comalco were formed to build an aluminium smelter over here in Southland. The site for the aluminium smelter was Tiwai Point, which is about 160 kilometres south from here, adjacent to the port of Bluff, which also happens to be a deep water port and absolutely ideal for the large ships that bring all the processed bauxite from Australia over here. So, as I say, way back after the Second World War, there was a worldwide thirst for aluminium for the aircraft industry and for the motor vehicle industry, and of course Australia had discovered massive deposits of the alumina ore known as bauxite, and they also did not at that stage have sufficient generation capability to make use of this. New Zealand, on the other hand, had a lot of hydro sites yet underdeveloped, and this was one of them. It was first recognised way back in 1904 that this was an ideal site for large or high generation hydroelectricity. 4 projects sometime in the future. And of course it almost happened in the early 1920s when they were planning to build a fertilizer plant over at Doubtful Sound, but that didn't quite get off the ground. They did all the plans and they had everything sorted to do it, but it didn't happen because something got in the way. I'm not sure what it was, but it didn't happen. The west coast of the South Island did not grow in the way they expected it to. So plans were shelved again. And they weren't revived again until the late 1950s. And of course, New Zealand government in the late 1950s offered this site to Australia. And Australia basically were granted the rights to build a power station here and build the aluminium smelter. They formed a company known as Comelco, and Comelco came over here and they basically they hired a company from San Francisco known as Pacific Corporation to design a power station and to do the exploratory examinations of the mountains, geological examinations, and they take time. So they did all those kind of things. And then late 1961, when it came time to start building the station, they had some financial difficulties which did not allow that to happen. They basically couldn't raise sufficient finance to build the station and the aluminium smelter. So the whole plan was shelved for another year, and then the New Zealand government wanted this program to go ahead. So they stepped in on behalf of the taxpayer, offered to build the station here, and the taxpayer would own it. Comelco would sign agreements for the guaranteed supply of energy at a nominated price, and basically that's what happened. Those contracts were signed, and over the years there have been many discussions about price, etc., etc., and the place officially started here in February 1963. Okay, it employed 1,800 men for a period of 8 years, and it was considered one of our country's most dangerous working environment. And when you think about where we are, you know, they didn't have the engineering tools that we have today. They certainly did not have the safety practices that we have today. Just over 1,700 men suffered a serious accident over that 8-year period, and 16 of them did not survive, as per the memorial plaque behind us. 5 of them in that first tail race tunnel that was drilled under the mountain to Deep Cove lost their lives down there. So a very dangerous place to work. Nowadays though, our workforce is rather small. We number up to 20 on a big day, really more than that, average around about 14 or 15. Most of us live locally, and there is a workers' boat that travels backwards and forwards Monday through Friday, and at the weekends and public holidays, well, the only ones working here are the tour guides, bus drivers. We have our guests here. The place just runs all by itself, because the staff here are basically maintenance and cleaning staff. The station is fully automated, remotely controlled from Wellington up on the North Island, and basically they use the telecommunication fibre cable systems to send their messages backwards and forwards. Water enters the station, as you might have heard Daz mention on the way down, through large penstocks that are drilled into the mountain. They're basically large tubes, about 3.5 metres average in diameter. There are about 20 metres in that rock face. There are 7 of them in there, one for each machine spaced out along the wall. Fully independent of each other, with gates, what we call head gates, on each penstock. Each head gate weighs 27 tonnes, takes 60 seconds to close. Okay, and just to ease your mind, this the chambers through here, the safety chambers, can hold 60 seconds of water flow. Okay, so we're relatively safe from flooding. Now we generate the electricity here by harnessing that energy, okay, because it's on a 180-metre vertical drop, and the energy in that water is kinetic energy and a huge amount of pressure, about 17.2 bar of pressure at the wicket gates around the turbine. So quite a lot of pressure. So we pass it through the turbine structure, which is like a big snail shell with a set of gates in the middle on a 360 degree wicket gates, and the turbine runner, which is the big wheel, sits inside that, and there's a massive shaft comes off that, drives the generator. So that's the very basic. So the water flows through this, around the snail shell, or what we call the scroll case, and dumps through the perimeter of the turbine runner and dumps out the bottom. So it comes down there, in the side, through, down and out, and heads out that way. Okay, there's a large manifold built way down below us over to the left-hand side, which is the downstream side. That manifold's connected to each of the 7 units, and that's where it collects all the water. Okay, and then that's connected off further down into the 2 tail raised tunnels that take the water out to Deep Cove and Doubtful Sound. Those 2 tunnels are approximately 10 kilometres long each. They get as low as 44 metres below sea level. Okay, we basically have to kick the water out of the station, speed it up on the way down, and then slow it down at the other end. That gives us a little bit of negative pressure on that downstream side, helps the water to flow through. Now it takes about an hour, by the way, for that water to make the journey through, especially on this kind of load that we're producing at the moment. Now we have 7 machines. One of them was always meant to be a spare, and basically from time to time we do have 7 machines running. We can generate 850 megawatts of energy, which makes us the largest hydro station in the country. Now we're generating about 715 at the moment. We've been up as high as 725 today, just off 6 machines, because unit number 4 down there is out for some serious maintenance. It'll be out of action for 3 or 4 weeks, or 2 or 3 weeks I should say. We're doing some major upgrades on the large transformer that is there and behind those doors down the left-hand side. At that level of generation, we're consuming about 470,000 litres of water per second from the lake per second. Yeah, it's a huge amount of water, and it's pretty hard to believe that 1,000 litres of water weighs a tonne. Okay, and when you're standing down below beside one of those turbines, just thinking every time you click your fingers, there's 80 odd tonnes of water passed through that turbine. It's quite mind-boggling, isn't it? So we have, this is known as the machine hall floor. We have 4 engineering floors below this one, and this area we're looking at is about 1/3 of the total excavation just for the machine hall. So it's a very big hole in the mountain. Now right down the far end, the large red doors down the far end, they lead through to the very first shaft that was drilled here, way back that exploration shaft by Camelco. And it is one of the 2 tallest lift shafts in the country. One of them being the 220 metre lift shaft at the Sky Tower in Auckland, which I've just recently travelled in, and the other 3 are only 192 metres tall. This one's 220 as well. It takes 2 minutes and 12 seconds to come from the top to this floor down here, which is the bottom, as far as the lift goes. Now we only use that Monday through Friday, because basically it's an old lift. It's well maintained, but Murphy's Law says that it'll break down when there's no one around to let you out. And that's what happens on the weekends, because we're the only ones down here. So we don't use it at the weekends at all. These large cranes, or these gantry cranes in front of us, there's a 15-tonne hook and a 150-tonne hook on each one of them. These were the single longest pieces of machinery that came down the tunnel. These took many, many hours to reverse down. They come down on one piece, and the curves of the tunnel are just so these will fit down. There wasn't anything to spare. Okay? Okay, look folks, that's probably enough. We have some brochures over here to my right.